Hi mga katropang kabus. Bago na po akong sa uniform, pati akong bag blue na, gubao na to akong pula, palitag bag ko sunod. Nawala ko. I'm going to the what do you call that place again? There's a community midway to Agad Agad. So, and it can be accessed through this concrete road. I was wishing I would go to the climber's path, the climber's trail, but every time I ask people around there, they would always point their fingers to this direction because maybe it's kind of business for them, that if you'd like to go there, and you don't just have to ask them which is the trail. Instead, you hire them as their tour guide. But that's not my intention. I'd like to discover it myself. That was my plan, but I asked 4 or 5 people, and they point to this direction. Okay, so now I'm in a concrete road and we're ascending. So the path ahead is going up. This is a boring climb because your pace, your steps would be just, it would be repetitive, same step. Unlike when you are using the climber's trail, then you'll have a different kind of, areas to pataka na pud ko. You have different experiences. There are rocks, there are, sometimes the trails are from afar. You don't know where it leads you to, but as you get there, you will discover the trail ahead. And sometimes you have options to slightly skip this portion and instead go around that portion. For example, if there are boulders, if you think some of the stones are loose, then you can go around them. But here, see, it's like it's same same routine all the way up. So it's like, walking up downtown Seoul, Korea, where the roads are also hilly, in Baguio City. You can see the road ahead, and you just tell to yourself, layo pa. Kung saan pa kumabot diha. Hi. There's nothing to talk about yet. So, I don't have a topic also. How about inner loops. for, for example, 3, the depth of the loop is 3. From I equal to 1 to n, j equal to 1 to n, and for each j you have k from 1 to n, for which the runtime is n cube. That's the cubic. The asymptotic behavior would be cubic. Is it bad if you have a runtime that is cubic? The answer is generally yes. It's worse than quadratic, or far worse than linear. But that's the general answer. It's not good. So what are the cases that I think there's only one case that I can think of for which cubic asymptotic behavior of cubic is not really that bad. Example, if your n is just 10, so that simply is about 1,000 iterations at the jth level. So if that would be a depth first or breadth first search, the number of nodes would be just 1,000, and that's not really bad nowadays, given that we have more powerful machines and multi-threaded processors. Most of ordinary desktops nowadays are equipped with 8 cores, and the market today is releasing new versions of new generation PCs which has RAM of 16 gigabytes and of course with 16 threads. So although that would not significantly increase, or that would not help alleviate or improve the asymptotic behavior, but in terms of actual performance it does, especially if your n is as small as say 10 or 20. But given nowadays the volume of data is so massive, if we just talk of, for example, pictures that are taken all throughout the world in just one day, then that would be a lot of data already. And if that number would be your n, then n cube is something that should be avoided in the runtime performance of an algorithm. Avoided. It means that there are occasions for which it is inevitable to use algorithms. So if that would be the case, what are the alternative solutions to improve the actual performance, given that the hardware is already doing its part in accelerating accelerating the improvement of executing basic operations? They're already doing it as fast as the lightning. As fast as the lightning. As fast as it could. Well, others do amortizations. If you cannot do if you cannot do optimizations like search pruning, pruning of search space, like in chess, you have to early on in the runtime, if you think that a solution is not feasible on that branch of tree in the search space, then you should not go down there and waste your time. If the probability that you cannot find a solution there is within the threshold level. Otherwise, you have to go down there. So if you have a lot of these optimizations and pruning of search space, then the actual performance could be reduced significantly, but this is not predictable. So worst case is still n cube. Bye. So lesson number 1.